Hello everyone. I'll be talking about federated learning for climate change. My name is Rakshit Naidu and I'm a final year undergraduate student at MIT Manipal. So before moving on to federated learning, let me talk about what machine learning actually is. So machine learning relies a lot upon your input data, and this data is run over statistical algorithms to evaluate and generate future predictions. Machine learning models have become more and more complex over the years. An example for this would be the BERT model, which was a complex model that was on top of the leaderboard in 2016 for language-based applications. Now, BERT has become the most prominent model for natural language processing applications. So with these advancements, there's a possibility for models to actually learn more than what is necessary, and models could also learn on sensitive information. I'll be talking more on data privacy later in this presentation. So let's move on to machine learning for production use cases. Here we deploy a machine learning model to a server, and each of the client in the protocol sends in their own private input data to that server in order to run this machine learning algorithm. And once this model actually runs over that particular client's data, that particular client could actually extract the predictions that was generated in that server. But what if the server is malicious? The server could actually send each client data to sell each client data to third-party data vendors, which could be very harmful and could pose a huge risk to the privacy of each client. So the solution for this was federated learning that was actually developed by Google researchers in 2016. So here what we do is we have a global model that is deployed at the server, and this global model is also sent to each of the clients in the protocol. Once these models are actually sent to each client in the protocol, these models run locally on each client's data, and each client could also generate inferences locally on the edge and without actually sending their own private data to the server. So once that model has been run locally, this model could actually aggregate on the server, and the then global model now becomes the updated global model that is being sent to the server. So in machine learning, the data is actually brought to where the model resides, that is at the server. But in federated learning, what we do is that the model is brought to where the data resides, that is on the client's devices. So here is another picture on how the server actually aggregates each of the user updates into a new model. This aggregation is actually done using the averaging method. We actually take each model from each of the n clients and we average them. The most important federated learning application is the smart keyword suggestions that one sees while typing. So when texting, you can actually see that these keywords that was generated is actually catered to your own private data that the model has been trained upon. So this is a natural federated learning application, and I'll be talking more on federated learning applications for climate change also. So the next property of federated learning is that the data actually tends to be unbalanced because it varies. The usage statistics vary from each user. So one user could actually use a lot of their mobile device while the other would not. So it really gives rise to a lot of data imbalance. So let me summarize on why federated learning. It actually allows you to train on local data, thereby creating personalized models. And we also understand that the usage statistics varies from user to user, so the real-time data is always unbalanced. So federated learning actually allows you to create local personalized models, as these models are trained on one's own data. It also preserves the privacy of that particular client's data, in contrast to the conventional ML approach, that is when the server is malicious. So before moving on to federated learning for climate change, let me tell you my background on it. So last year I had some background knowledge in the federated learning space, because I contribute a lot to the open source society called Open Mind. And with the knowledge that I had gained, I decided to target a workshop called the Climate Change AI workshop at the NeurIPS conference. So the NeurIPS conference is actually the most elite conference in the AI space. And this year in 2020, in August 2020, there was this mentorship program that was released by that same workshop. So I decided to apply for it using this idea of combining federated learning and climate change. So once I had done that and I had gotten selected, and I was paired up with a mentor at Germany, who's actually an esteemed professor who specializes in climate change. We discussed a lot on the applications of federated learning for climate change, and with that we actually were able to submit a paper to this workshop. So coming back to the presentation, let me talk about why federated learning for climate change is important. So there is always a need to procure quality, privacy sensitive data for understanding climate change. So having these personalized local models pertaining to each user actually gives us access to good quality data, and one can also use this data to gain better insights on real-time short-term weather patterns. And once we understand the short-time weather patterns of any particular region, we can actually try to understand climate change. So most of this data actually resides on local devices of the users. So there are laws like GDPR and CCPA. The GDPR refers to the General Data Protection Regulation that was released in 2016, and the CCPA refers to the California Consumer Privacy Act in 2018. These acts actually hinder corporations or individuals to work on the client's private data. So privacy has become a huge notion in the West and is slowly getting adapted in the East as well. So we developed a typology for federated learning solutions for climate change. So here you can see a table that we created. We actually classify climate change into two different categories, that is climate change adaptation and climate change mitigation. Under adaptation, we talk about the individual efforts and the collective efforts, while under mitigation, we talk about grid optimization, shared mobility, carbon footprint, and even data retrieval. So let me talk about climate change adaptation. So climate change adaptation actually refers to how we as humans adapt to the constantly changing climate. And when we talk about individual efforts, in order to prepare for adverse events like storm surges or hurricanes, we actually need more environmental data. And with more environmental data, we could actually generate more localized predictions of short-term weather patterns. An example for this would be the El Nino and the La Nina phenomena that affect almost every continent yearly, but in a highly variable fashion. So there are new tools that we could also use new tools to predict daily heat exposure, combining external weather data with the local scheduling data, and also advise on precautionary measures such as avoid on-street walking in this city quarter X between noon and 6 p.m. So now let's talk about collective efforts. So we could also introduce federated learning for specific regions that cater to humanitarian relief efforts. Now when I say humanitarian relief efforts, we could actually deploy these models to each of the clients in a particular region, and if this particular region sends in abnormal gradients or abnormal updates to the global model that resides on the server, we could actually learn that and say, okay, this region is not performing well, maybe there's something bad happening in this region in terms of climate change. So this is really important because federated learning actually allows you to run this protocol over a large number of clients, and you actually don't need to trust only one single source that saying that okay, this region is not performing really well in terms of climate change. So now let's talk about climate change mitigation. So climate change mitigation refers to how we as humans tackle climate change, because climate change right now only mostly refers to the global warming that is produced by greenhouse gases emissions, and mitigation refers to how we try to reduce the emissions of greenhouse gases in the atmosphere. So the first solution for this would be the grid optimization. So federated learning could actually allow analytics to be derived without even sharing raw sensitive energy consumption data. So the electricity grid could also be one area that could be looked into using federated learning. Another solution for this would be shared mobility. So there is a vast amounts of data that's collected by sensors in vehicles. So this should be considered sensitive because it could reveal behavioral patterns of each of the transport users. So we could actually perform federated analytics on this data that actually stays on vehicle. So the next solution is the carbon footprint. So we could actually use mobile applications to translate mobility behavior to carbon dioxide footprints, and thereby learning the carbon intensity of mobility data by federated learning. And the last point is the data retrieval. We could actually derive different features, that is wind, rain, temperature data of the same region, and we could collect them and conduct an in-depth analysis on how climate change affects that particular region, and how each factor also affects that particular region's weather patterns using vertical federated learning. So now let me talk about data privacy. So some of this data could actually be useful in mitigating and adapting to climate change, such as the electricity and gas usage data, but this is legally not considered to be personalized identifiable information. However, individuals might also want to protect this data, because in order to avoid embarrassment or any social stigma that derives from their personal contributions to climate change. So not all data is actually under the ownership of the individual, but it actually depends on the organization that owns the data collection software. An example for this would be the vehicle mileage and mile per gallon that may be in the control of the vehicle manufacturer. So let me talk about the disadvantages of federated learning. So in federated learning, you actually run these models n times over all the n clients, which actually increases the computational costs. However, we also need to understand that the main advantage of federated learning is that we train the model on real-time data that lives on the mobile device in order to gain insights on short-term weather patterns, or maybe even long-term weather patterns. The next point is that scaling federated learning to production use cases is also a major hindrance in this space, because of these expensive costs that incur during creating such a heavy infrastructure. So there is a need to conduct more research on these different trade-offs. To perform on-device training, the clients also need to stay in ideal environmental conditions. That is, they need to be charging, or they also have reliable network connections. So there is a research paper that talks about how many developing countries don't have the feasible conditions to run federated learning. So to conclude this question that says that will people from developing countries actually care enough about data privacy to require federated learning, or is it actually necessary? Like, would you actually need data privacy if you have just got reliable access to the internet connections? So this is something that needs to be looked into in the future. I thank the TEDx volunteers and my collaborators for helping me out in this project, and thank you.